Okay, let's move on to the second section of Chapter 3, and it is titled Solve Two-Step Equations. So we're going to step up the complexity a little bit of the equations that we're going to solve. Okay, so now we're going to solve using not one, but two steps. Okay, what have I been saying in class? Go to the unknown, go directly to the unknown. Now, why am I saying that? We need to identify the operations around that unknown. So go right to it, look what's around it, and identify the operations around it. Okay, let's look at a specific example here. 3x plus 7 equals 19. Now, in this case, we have a couple of operations around it, and I want you to identify those in a specific order. I want you to follow the order of operations, or PEMDAS. Let's write that down. All right. So the first thing, go directly to the unknown. Here's x. Look at order of operations, and what is the first thing you encounter here around x? The first thing we encounter is multiplication. So write that down. X is being multiplied by 3. The next thing that's happening in the order of operations is we are adding 7. So identify adding 7. Now we are going to reverse these or undo these operations in the opposite direction of PEMDAS. So it's kind of like a big circle, okay? You're going to use order of operations to identify them, and then you're going to go in the opposite direction to undo them. So we're going to undo adding of 7 first by subtracting 7, and we're going to next undo the multiplication by dividing by 3. Let's see what that looks like. All right, so we've got adding of 7. We're going to undo first with subtraction of 7. 3x comes down. Opposites, when they add, cancel to 0, and 19 minus 7 is 12. Now we're going to undo that multiplication with division. So this is our second step. Of course, anything divided by itself reduces to 1, and 12 divided by 3 is 4. Now I want you to check your answer, always is a good idea, by first writing down the original equation and substituting. So we think x equals 4, but let's check by substituting x equals 4 into the equation. What do we hope to see is true equality. Using order of operations, 3 times 4 is 12, and then 12 plus 7 is 19. So everything checks out. We get true equality. All right, let's take a look at a couple of examples. And again, the very first thing I want you to think about when solving equations is order of operations. So let's write that down, and I want you to refer to it often as we identify the operations and as we undo the operations. Okay, so first example here, we've got x over 4 minus 12 equals negative 5. What operations are around x? Go directly to the unknown. Using order of operations, x is being divided by 4. Let's write that down. And we are subtracting 12. All right, I want to go in the opposite direction to undo these operations. So I'm going to write down the original equation. We want to undo the subtracting 12 first because that's at the bottom. We're going to go from the bottom up now when we undo. So I want to undo subtract 12 with add 12. Whatever we do on one side, we got to do on the other. X divided by 4 comes down. Of course, opposites reduce out to 0. And we've got a negative 5 plus 12. Different signs, take the difference and give it the sign of the number farthest from 0 on the number line. So that will turn out to be 7. Now we want to undo this x being divided by 4. We're going to undo that division with multiplication of 4. Whatever I do on one side, I got to do exactly the same thing on the other. A number divided by itself reduces to 1, and 7 times 4 is 28. We think that x equals 28, but of course we need to check our answer. So we're going to go back to the original equation, and we're going to substitute, and we hope to see true equality if our answer is correct. So substitute 28 in for x. Kind of asking ourselves a question, that's why I'm putting a question mark here. Order of operations says that we need to do division before subtraction. So we are going to divide 28 by 4, which is 7. And we hope to see that 7 minus 12 is negative 5, and it is negative 5, so that checks out. All right, let's look at the second example. Go to the unknown, go directly to the unknown. What's around it? We have multiplication of 7, and we have a subtraction of 14. These are the two operations that we need to undo in the order in the reverse order of the order of operations. Okay, so let's see what we have. We're going to undo that subtraction first with addition. Whatever I do on one side, I have to do on the other. So 7k comes down, combining opposites reduces to 0, and we have 56. Now, k is being multiplied by 7. We're going to undo that multiplication with division. Whatever I do on one side, I got to do on the other. 7 divided by itself reduces to 1, so we successfully have k by itself, and 56 divided by 7 is 8. Okay, so we think k equals 8, but we need to check our answer. So the first thing we're going to do is write down the original equation, 7k minus 14 equals 42. And we're going to substitute 8 in to see if we have true equality. We're going to see if that does equal 42. 7 times 8 is 56, minus 14. We're asking ourselves, does that equal 42? And you might want to do some long subtraction here. 6 minus 4 is 2. 5 minus 1 is 42. So we do have true. Okay, one more thing to talk about before we end this video. It's a good idea to simplify both sides of the equal sign separately before you start to do any kind of inverse operation. So what do we mean by simplify? We mean combine all like terms. Remember, like terms are those that have the same variable with the same exponent. And all constants, those are pure numbers. Pure numbers are always like terms to each other. All right, think again about order of operations. So I'm going to write that down. All right, let's look at this example here. We have 5x plus 4x plus 9 equals 36. Well, we see here on one side of the equal sign we have some like terms, 5x plus 4x. So it's a good idea to simplify that first before doing any inverse operations. 5x plus 4x is 9x. So here we look at what we have after combining those. We have addition of, we have multiplication first of 9, and we have addition of 9. So what order do we want to undo those? We want to go from the bottom up. Okay, let's write down the original equation here. We've got 9x plus 9 equals 36. And the first thing we're going to want to undo is this addition of 9. That is bottom up, so we've got to undo that addition first. Alright, so we have 9x coming down, of course opposites added together reduces to 0, and we have 36 minus 9, which is 27. Now I'm going to undo this multiplication using division. And 9 divided by itself is 1, and 27 divided by 9 is 3. Alright, when I check my answer, it's a good idea to go back to the original, the very first equation. So I am going to do that. I'm going to write it down, which is 5x plus 4x plus 9 equals 36. I'm going to check out my answer by substituting 3 in for x. Notice I'm being really careful to use parentheses to show my multiplication. Alright, we have multiplication here, we have multiplication here, and then we have addition. We have to do multiplications from left to right first. So 5 times 3 is 15, plus 4 times 3 is 12, plus 9, and we're hoping this whole thing equals 36. We have addition left. We have to work left to right on addition. 15 plus 12 is 27, plus 9 equals 36, and finally 36 does equal 36, so everything checks out. Alright, one more example here, example 4. Again, simplify before doing any inverse operations. So here we do have some like terms on one side of the equal sign, so we're going to want to combine those first. 5y minus 2y is 3y. Minus 3 equals 6. Now there's nothing more to simplify on either side of the equal sign, so we're ready to identify what's around that unknown. So go directly to the unknown. What's around it? We have multiplication of 3 and we have subtraction of 3. We're going to want to undo those from the bottom up. So we're going to undo that subtraction first. Let's rewrite our simplified equation here. So undoing that subtraction first, we're going to undo that with addition. I have 3y. Coming down, of course, the opposites reduce to 0, and 6 plus 3 is 9. Now I'm going to undo that multiplication with division. Of course, I got to do that on both sides. And we have successfully gotten y all by itself here. 3 divided by 3 is 1, and 9 divided by 3 is 3. So let's check out our answer. Again, we got to go back to the original. 5y minus 2y minus 3 equals 6. 5y minus 2y minus 3 equals 6. Substitute 5, and that's multiplication between the 5 and the y. So I'm going to show that with my parentheses. Alright, order of operations. We've got multiplications going on, we've got subtraction, more multiplication. We have to work multiplication first. 15 minus 6, 2 times 3 is 6. We're hoping this whole thing equals 6. Now we're down to subtraction. We've got to work left to right. 15 minus 6 is 9. And 6 does equal 6. So we successfully verified our answer. Thank you.